Okay, Unit 9 is about circles, and you've probably talked about circles in middle school for a bit, and we're going to review those concepts and then expand on them to learn some new things. So here are some definitions that you may already know, and we're going to draw pictures to kind of help us. So we all know what a circle looks like, but the actual definition of a circle is kind of confusing. The definition says the set of all points in a plane equidistant. Okay, equidistant means that it's the same distance apart. So the set of all points in a plane equidistant from a given point. So what that basically means is that if I have a point in the plane, we call that point C, and let's say I have a bunch of points that are 5 centimeters away from that point C. There's an infinite number of points, and if they're all 5 centimeters away, that does form a circle. So that's the mathematical definition of a circle. And you may say, well, why do I need to know that? I've actually seen this on the SAT before, where they don't say, hey, this is a circle. They give you the formal definition of a circle, and you have to realize, oh, they're talking about a circle. Now, if we're writing the name of this circle, we would say this is circle C. That is how we would write that. Now, a radius, so if we have our circle again, and I'll draw it better this time, the radius is any segment that starts at the center and goes to the edge. So this is R. And we could have more than one radius. We could have a radius like that. And the plural of radius is radii. All radii are congruent or equal in measure. And then a chord of a circle is any segment whose endpoints are on the circle. So this is a chord. This is a chord. This would also be a chord. So as long as your two endpoints of your segment are on the edge of the circle, that is a chord. Now a special type of chord is a diameter. A diameter is a chord that goes through the center of the circle. So that is a chord. That is a diameter. This is also a diameter. So just like radii, you can have an infinite number of diameters. So let's look at a picture and identify parts of a circle. So remember, radius starts at the center and goes to the edge. So we have radius LR, LW, and LT. So that's segment LR, segment LT, and segment LW. Those are all radii. Now diameter, so remember diameter has to go from one side of the circle to the other and through the center. So we only have one diameter here, and that is segment RT. Now chords, remember the diameter is a chord. So one of the chords we have is the same thing as the diameter, RT, but we also have RS and ST. And then finally, to name the circle, we go with the center, and we say that this is circle L. Alright, let's flip the page. Now on this page, we're going to talk about the circumference of a circle. The circumference is the distance around the circle, or you can think of it as the perimeter of a circle. And there's two ways that we can calculate that. One of them is to multiply the number pi times the diameter, or you can multiply pi times 2 times the radius. They equal the same thing because the diameter is equal to 2 times the radius. And that should make sense. If the radius is from the center to the edge of the circle, and then the diameter is, think of it as 2 radii together, and that forms your diameter. So 2 formulas we can use are pi times the diameter, or a lot of times it's written as 2 pi r for writing the equation using the radius. It doesn't matter how you write it. So let's look down here. In example number 1, we're going to find the exact value. So when you see that exact value, that means leave pi in your answer. Because pi is an approximation, we all know that pi is about 3.14, but it keeps going on forever, and when we use 3.14, that gives us an estimation, not an exact value. So anytime you're asked to give an exact value, we're leaving pi in our answer. And then we're going to round to the nearest hundredth. So in example A, we're given the radius. So I'm going to use circumference equals 2 pi times the radius. Then we can plug in 8. So C equals 2 times pi times 8, which we know that to be 16 times pi. Because we multiply our two numbers, 2 times 8 is 16, and then we are asked to leave pi in our answer. The second part does say to give a decimal approximation. So I'm going to type that into my calculator, 16 times pi. If your calculator doesn't have the pi button, you can use 3.14. Just know that you might get answers that are slightly different than mine. And I get 50.27. Here's my decimal approximation. All right, now letter B, I'm given the diameter, so I'm going to use the formula pi times the diameter. That gives me circumference is equal to 13 pi. It doesn't matter which order you write it in, because multiplication can be done in any order. So you could write pi times 13, it doesn't matter. And then my decimal approximation is 40.84 inches. All right, then example C is a little bit more complicated because we're asked to find the radius, but we're given the circumference. Okay, well remember that the circumference is 2 pi times the radius. Well, if we know that the circumference is 65.98, we can plug that in for the circumference here. So 65.98 equals 2 pi r. So then we need to get r by itself because it's the radius. That's what we're asked to find. So you can divide both sides by 2 pi. Now I'm going to show you something on the calculator that will mess you up if you're not careful. So you may be thinking, all right, let's just do 65.98 divided by 2 pi. So pi is the second button and the exponent key. And you get 103.64. Now that should trigger your mind to say, wait, something's wrong. How can the radius be bigger than the circumference? That makes no sense. What you're telling the calculator to do is you're taking 65.98, dividing that by 2, and then multiplying that answer by pi. That's not what you want. You want to divide by 2 times pi. So put that part in parentheses, and there we get our radius of 10.5. All right, let's look at example number 2. So in example number 2, the question says, if the tires on my car, not care, have a 17-inch diameter, how many miles have I driven after the tires have rotated through 1,000 revolutions? So what we're first going to do is we're going to find the circumference of the car tire. The diameter is 17, so circumference equals pi times the diameter. Circumference equals pi times 17. And that will equal, if we type that into our calculator, we get 53.41. So 53.41 inches. Now, I'm going to convert that into feet because the question is saying how many miles are in 1,000 revolutions, and we have this hint here to convert miles into feet. So I'm going to take this 53.41 divided by 12. And I get 4.45. So the circumference of my car's tire is 4.45 feet. And remember how we talked about that this is also the perimeter of the tire, the perimeter of the circle. So every time the tire rotates, the distance that we travel is 4.45 feet because the whole tire is made one revolution all the way around. Now, we want to know how far this has gone in 1,000 revolutions. So what we're going to do is we're going to take this number, 40.45, and multiply it by 1,000. So 40.45 times 1,000. And I get 4,450. 4,450. So that's how many rotations, that's how many feet I have traveled in 1,000 rotations. Now we got to convert that back into miles. So then I will do 4,450 feet divided by 5,280 feet. That's how many feet are in a mile. And that will equal, so let me type that into the calculator, 0.84 miles. So to kind of recap, we first had to find the circumference of our tire, which we did on the left side over here. Then we had to figure out how far does the tire move or rotate in 1,000 revolutions. So that's why we multiplied by 1,000. And then we divided that by how many feet are in a mile to convert that to miles. All right, now let's look at the last example. It says a satellite around the Earth is in a circular orbit 200 miles high. Assume the radius of the Earth is 4,000 miles. If it takes the satellite 2 hours to make a complete revolution, then how fast is the satellite traveling in miles per hour? So what we have is we have the Earth here with the radius of 4,000 miles, and then above the Earth, 200 miles, we have the satellite orbiting. Now what we want to do is figure out, all right, what's the radius from the center of the Earth to where the satellite's going? Well, that's going to be this 4,000 here plus this 200. So 4,200. Now, if the radius here is 4,200, we can calculate the circumference, and that will tell us how far the satellite is moving across the Earth. So circumference equals, and since we're given the radius, we're going to use 2 pi r. The radius is 4,200, so circumference equals 2 pi times 4,200. So we type that into the calculator. 2 times pi times 4,200. And the circumference is 26,389.38 miles. So in one revolution, that is how far the satellite moves. It moves 26,389.38 miles. So the question is asking, if the satellite, if it takes the satellite 2 hours to complete this revolution, so it takes the satellite 2 hours to make that full circle around the globe, then how fast is the satellite moving in miles per hour? Well, this one you might just think, well, just divide by 2 because, well, if it goes this far in 2 hours, divide by 2 to get how fast it goes in 1 hour, and that will work. Another way to do it is what I call the DIRT equation. D equals rate times time, DIRT. We know the distance is 2,638, or 26,389.38, and that equals, well, we don't know what the rate is, but we do know that it takes 2 hours. So then we divide both sides by 2, and we get 13,194.69 miles per hour. Okay, so again, to kind of recap, first we found the circumference of the bigger circle because the satellite is 200 meters above the Earth, not meters, like 200 miles above the Earth. So we found that circumference, and then again, that's the distance that the satellite is traveling around the world. And then we had to use this, what I call the DIRT equation, to figure out the miles per hour. So hopefully this is a good refresher and that you learned something new. So again, try your best and ask questions if you need to. Bye.